Today we are reviewing the lab, so maybe that's partly why people are late. So that's the first thing we're going to do because I just realized I did request people not attend if they weren't done with the lab. So let me switch my share over to our studio, and we'll go through this real quick. Okay, so this was the one where we were looking at 538 data. So you were installing those packages, and then I was asking you to do some things with scales and color scales and switching between continuous and discrete and things like that. All right, so we'll just walk through this kind of line by line, loading our packages, setting our theme, and then again, I'm setting the base at 15-point font, but you know that number is going to vary probably mostly by your output. Okay. Let me shrink this up so it's hopefully a little more visible. All right. Then the first part was just asking you to plot hurricanes, basically lines for different hurricanes. So if we look at the Google Trends data, it looks like this, right? So we've got the date and then the different hurricanes and then the interest for the hurricane, right, on the Google Trends. And so this is a great format if we're trying to communicate the data through like a table. But most of the time when we're analyzing data, this is not what we want, right? We essentially have one variable here, hurricane, that's stored across a bunch of different columns. And so to plot this, we need to move those hurricane columns all into a single column for the hurricane. So that's where we're going to use pivot longer, right? I'm going to say starts with hurricane. So get all the columns that start with hurricane, and then put these names, what are the current names of the columns, into a column that we're going to call hurricane. And then all of these values down here, we're going to put into a new column called interest. Okay. Now, from here, that's all you really have to do to get this to work. But one of the things that's nice about pivot longer, and I know some of you are still using gather. I used gather for a long time, but and I was a little bit slow on adopting pivot longer, but it does have some nice features like this that help make things a little more efficient. So one of the things is you can rename the old column names right within your pivot longer. Okay, so what I'm doing here is basically passing an extract code. Okay, so this is, excuse me, this is a regular expression. It's a very simple regular expression. So I'll just walk through what this is doing. But essentially what I'm going to try to do is pull out just the name of the hurricane and drop everything else, because hurricane underscore and underscore US is just redundant, right? I don't need that every single time. So what I can do is say names pattern, and then I'll put an underscore, which is going to say search for the underscore, and then grab everything until the next underscore. Okay, so that's what everything in these parentheses is what it's going to grab. Okay, and the dot just means any character, and plus means any number of times. So this works because Harvey is a different length than Irma, right? So I can't say like the whatever 5th through the 12th characters or whatever. I'm trying to say here's a pattern, an underscore, and after you see that pattern, match everything until the next underscore, right? Does that make sense? So that's what's going on here. And then when I look at G after I do this pivot longer, it now just looks like this. Okay, so we've got the date, the hurricane, and it's just the name of the hurricane, and then the interest. If we wanted to, we could also make this a little bit nicer where we could pass this straight to mutate and say hurricane is equal to string to title hurricane, right? And then that's going to give us something that looks now like this. So these are all in title case, right? And so that might be a little bit nicer for our plot also. I tried, you can't actually do that mutate right within here. So you do have to pass it to a new line. But that's a pretty efficient movement of data and changing the names. Okay, so then the next one's pretty simple. once we have the data in the right format, we're just going to put date on the x-axis and interest on the y-axis, and then do geom line where color is equal to hurricane. So that gives us something that looks like this, right? Let me bring it out just a little bit more. Okay. So you can see the base size is a little bit big for this size of plot, but that's not that big of a deal. I'm not concerned about that right now. All right, so then the next part was to visualize the same thing, but using solid shapes instead of lines. So basically, I'm just asking you for each of these lines to fill in the background, right? And so the way I would do this, and there's a couple different ways, but to me, the best way is to do this with geom ribbon, okay? So now you're going to say the y min, the minimum for the y, is going to be 0. So it's going to go extend all the way down to 0. The y max is going to be interest. So that's going to be the same as our line before. And then we're going to fill with hurricane. All right, I'm going to say color equals null. You could also say color equals hurricane, or you could say color equals, you know, white or black or whatever. But I kind of like the color equals null because that just basically takes off the line on each of these, okay? And alpha is equal to 0.6, so we get a little bit of transparency down here, and we can kind of see the other shapes, okay? Now I was asking, let's see, oh, this is the part where now we were going to switch the, I don't know why I have this max date here, but maybe that'll come up later. So basically here now we're going to switch to filling with a continuous palette, right? Instead of a using color to map to a categorical scale, we're going to use color to map to a continuous scale. So all that means is that we're going to have date as a categorical variable now, and the hurricane as a categorical variable, and then we're going to fill based on interest, okay? So we take our G, we put date on the x-axis, hurricane on the y-axis, and that just gives us something that looks like this, right? Just a bunch of squares, or rectangles rather. Then I'm going to use geom tile and say fill equals interest. Notice I'm saying color equals gray 90 here. That's because the color is going to map to the outline of those shapes, whereas the fill is obviously going to be the fill of the shape. So when I do that, I get something that looks like this, okay? I don't know that gray 90 is the best. You could make arguments that something else would be better. I'm not sure why I settled on that in this case, but I did, okay? Then I'm going to switch the color fill. And I didn't ask you to do this, so if you didn't do this, it's fine. But I'm using a palette from the Sicko library, using this Devon palette, which is like a blue to purple sort of thing. Then we're going to just add chord fixed. Again, this is sort of optional, but I think it makes it look better generally. This is hard to see because it's so small now. So one of the things I like to do with heat maps is put the legend either on the bottom or the top. So here I've decided to put it on the bottom and make it horizontal. It actually does that by default. But then I've changed the size of that legend too. That's what those two things do, okay? So then we get something that looks like this. Again, because of the plot being so small here, we've got a lot of overlapping things. But generally, this is what we want, right? We're most of the way there. And if I do this zoom, you probably can't see it. But let me just do this real quick. Okay, so you can see that now, right? Okay, so this is, I think, now a pretty good plot at this point. And this has to do with aspect ratios and things, which we will talk about more actually today. All right. Okay, so now I asked you to annotate it with some vertical lines. So all I'm going to do here is create a new data set, which I'm calling landfall. I'm creating a date where you can, this is one of the, I think the nicest functions about lubridate is you can use these MDY, DMY, YMD, whatever, to basically parse out the date. So you can put the date in a string over here in whatever format feels most natural to you, and then just use lubridate with the corresponding one where M obviously is month, D is day, and Y is year. And then that'll transform into a date. Then I'm saying hurricane, and I'm just listing what the 3 hurricanes are. Okay, so that gives me a new little data frame. that looks like this. And then I'm going to basically have what I had here before, date and interest, geom ribbon, but now I'm adding this geom v line where I'm saying the x-intercept is equal to the date, okay? And then the data is from the landfall data set now instead of the full data set, changing the color to gray 40 and the line type to dashed, okay? There's a couple of different ways you can specify the line type. For whatever reason, I think it is line type, like the full word, but this is like the base R plotting abbreviation, and it's just what comes naturally to me. So that's what I do, LTY, right? But other ones will work too. So those are the lines, and then if you wanted to do the text annotations also, you can just put X, Y, right, with geom text, with landfall, and then notice I have this nudge X equals 2, okay, and that's going to nudge it along the X axis a little bit, and we end up with, oh, that's a bunch of stuff, sorry, that's a bunch of theming stuff that I was not planning to get to yet. So then it looks like that. Again, if we switch over to here, you can see that looks quite a bit better there. Still probably not all the way. But then from here, I can change the labels because the next part, right, was to make any other updates you wanted to. And then I use scale fill brewer and scale color brewer, and then a bunch of theming stuff. This came from using that GG theme assist to start, and then I made a few things from there. So that does end up looking like this, basically. The thing that is hard about this always is the aspect ratio, right? Especially when you're looking at annotating things with text, because I can't tell you how many times I have created something like this, gotten all the text to line up perfectly so it looks great, and then I go to save it and it looks totally messed up. And it's because I wasn't using the same aspect ratio, all right? So you do have to be careful about that. I'll show you a thing in the slides today where you can actually preview your plot with different widths and heights and things like that, okay? So again, this doesn't look that great here, but the way that I ended up saving it, it does look good, okay? All right, then the last part was to replicate that plot, or I guess there's two more parts. The first was to replicate the plot using the TV states. So again, we have the same sort of problem. TV states looks like this, date, and then we have the state, each state as a different column. So I'm gonna move this so that we have a column for the state and then a column for the percentage, all right? And this is actually a proportion, but whatever. And then I'm just so let's do that first. All right, that moves us here. But one of the problems is, and I'm sure many of you noticed this, when you're trying to replicate this plot, you end up with specific states that are overlapping in not the right order that they were overlapping. And so that seems like a difficult problem, but it's actually not that big of a deal. All you have to do is change state to a factor and then specify the levels of that factor in whatever order you want them to appear, okay? So here I'm saying state is a factor and the levels are Florida, Texas, and Puerto Rico, all right? So now when I do that, it's gonna look exactly the same, the data structure, of course, but state is now a factor and the levels are Florida, Texas, Puerto Rico. So that's how they will actually show up on the plot in that order, okay? I then created another data set to label the states. So there's a couple of different ways you could do this. This is the way I chose, right? So I'm saying state label is Texas, Florida, Puerto Rico, and then date, change that to a date, and then percentage, 1.5.9, okay? So I do that, and now I'm creating a second landfall one here again. So this is just like the previous one, but I'm now also including the Las Vegas shooting here. And then I'm adding line breaks between Harvey and between the name of the hurricane and whether it says landfall or shooting, okay? So that's another data set here, and it looks like this, all right? Now, from here, I mentioned earlier, right? You didn't have to replicate this thing perfectly. And you'll see I didn't replicate it perfectly, but I did go pretty far towards replicating it, in part because I know a lot of you do, even if I tell you you don't have to. So so I'm going to show you sort of how I got there, and I didn't get all the way there, like I said, but I got pretty close. And then, you know, maybe you have other ways that helped you get even closer. So the first thing is fonts, right? And we will talk about this more, but there's a package called Extra Font. There's another package called, I can't remember now, but will allow you to use Google fonts and things. Extra Fonts will just allow you to access other fonts that you have installed on your computer. Okay, I am not 100% sure what the font is that they used. I'm pretty sure, but the problem is you can't actually use like your developer tools to go and inspect the plot because it's just a ping, right? And so you can't look at the fonts within that very easily from like a web browser anyway. So I just said, okay, I'm going to change the font, but I'm not going to necessarily replicate their font. All right, so I chose to go with Roboto, which I think is a nice font, but it's not very close to their font. But I just wanted to illustrate changing fonts. Okay, so first we're going to just take ggplot, take this TV one, put date on the x-axis, percentage on the y-axis, and then use geom ribbon, where we're going to fill by state. Y-min is 0 and Y-max is a percentage. And then I'm putting the color as white, right? Because that's what they had. So that gets us something like this. Okay, then I'm going to add a vertical line for the landfall data, right? So I'm using landfall 2 now, and x-intercept is equal to date. Everything else there is pretty much the same as it was. Okay, so there's my 4 lines. Then I'm going to add a horizontal line at 0. And the reason is because if you look back at their plot, you'll see on their x-axis, it's a black line. All right, so I do that, and I get just a black line there for my x-axis. Okay, then their fonts for their labels had this shadow text thing. Again, this is not something I would expect you to do, but I wanted to show you in case you were interested. So there's a package called shadow text, and it uses this geom shadow text, right? And for the label, we're just going to put state label and then say the color and the background color, and then the family for the font, and then where the data comes from. Okay, so then I get something that looks like this. So you can see how this is like black with this white background. Again, if I look at it here, this might help a little bit more. See that? Right. Then I'm going to add the labels for these lines up here. Okay, so that's where I do geom label, put the label as the hurricane, and use landfall 2 again. Okay, and this is actually interesting because I'm using geom label, which produces like this this block, right? And actually, I'm saying the color is white, so there is text here that says it, but it's not actually doing anything. And what I'm doing is actually just setting up the spot where I want to plot these things, because I don't want that text to go over, like I want this white background behind it, okay? So then I do geom text again and do basically the same thing, and that's going to overlay that text on that white background. Does that make sense? So this is like, again, this is like super picky, not stuff I would expect for you to do, but I wanted to show you. All right, now we're going to just keep going. We'll do scale fill manual and use those 3 colors. Okay, and then and I can show you later how to pick out specific colors. I use a program called Color Slurp, which is very nice in terms of like you just like click on a color and it'll give you the color. All right, then we're going to change this y-axis. If you notice on the actual plot, it goes 0, 1, 2, 3%. Okay, so I said scale y continuous, change the name of it to share of sentences, and then is that what it said? Whatever. Break 0, 1, 2, 3, and then label 0, 1, 2, 3%. Okay, and that gets us there. Okay, and then same sort of thing with scale x date now, because the x-axis is a date. Change the labels so that they're like this, exactly like they had. I changed the expansion a little bit to, okay, now it's looking like this: August 15th, September 1, September 15th, August 1, October 1. Right. Say guides fill equals none. That's going to remove the legend. All right, and then change the title to National Cable News Network, right? And then just some final plot theming stuff here, and we get something that looks like this. All right, so again, this is Roboto font, which is not what they used, but whatever, I'm good with it. It's a different font is the main thing. Any questions on that? Okay, and I will post this too, so don't worry about that. All right, the last part was to use this comic characters data set and do something with gender, okay, and it was pretty open-ended. So I just first created a percents data set that looks like this, percentage of these different genders, and then I just did a couple of different things. So first is sort of exploratory stuff, looking at just a stacked column chart, and it's actually still, I think, fairly illustrative, right? Because you have a lot of things on your legend, but it's very clear that most are male, and then female is second most, but these other genders are just not really represented. Okay, so you can flip that if you wanted, and that looks, you know, like this, basically the same thing. So what I ended up doing is instead of doing a stacked chart, I just took the percents and I dodged them. And then I'm doing chord flip here. I could have just switched these things, but so we end up with something that looks like this. And I think this is actually quite a bit better than the stacked version because you can directly compare one gender to the others. Okay. Again, it could be argued that that's not the case. It depends on your purpose and everything. So this is just changing the expansion. But the other thing I wanted to do is actually label these directly. So instead of having this legend, I just wanted to label them. So, or no, sorry, I don't even need this legend at all because it's here, right? But what I wanted was to label the actual percent so that you don't have to necessarily walk down to the x-axis. So we get something that looks like this. This is a little bit cut off, but if you change the aspect ratio, it's there, right? And this is kind of weird here because it's like centered on there, and that's not really what I want. So
I don't think we're seeing the figure you're showing. I only see. Oh no, I see it actually on the bottom right. Before that was on A for a while.
Yeah. All right. So this is like the final version I ended up with. Again, these are like kind of messed up in this current aspect ratio I'm showing, but if you save it at a specific aspect ratio, then that would be fixed too. Okay. So this one was super open-ended. This is what one of the versions I chose. I haven't graded everybody's yet, but I saw some people were using pie charts. I think this is actually a case where you could make the argument that a pie chart is maybe the best that you could do. Okay. But I think this bar chart is super effective too, and it just kind of depends on what it is that you're trying to illustrate. If you're trying to illustrate proportion of the whole, which I think is a very reasonable thing to communicate, then maybe a pie chart would be preferred. If you're trying to directly compare two genders or multiple genders, then I would say this one is preferred. Okay. All right. Any questions on any of that? All right. So we are not going to get through everything today. I kind of expected this to start with, and then next class is fairly full too. But we do have like this built-in sort of fudge day near the end of the term. So it's we're going to try to just kind of, like my ideal is that we just move at a pace that feels comfortable and not like ridiculously fast. And then, you know, we near the end, we can have that day to sort of catch up if we need to, or review things that maybe we didn't cover quickly, or maybe we covered too quickly or whatever. All right, so today we're going to talk about axes and aspect ratios. We're also going to talk about plot annotations, and then we'll talk about themes a little bit. Themes are just not that terrifically important, I don't think, compared to other things. They're very stylistic, like what looks good to you. And I've actually had lots of conversations about this with people. It's sort of like fashion, really, in terms of like certain things are very in vogue right now, and like, you know, that's like it looks modern and clean and nice. and then you know, in 5 years that'll be out of style and there'll be something else. And then like I honestly think we're going to start rotating just like we do with fashion, in terms of like every 20 years things come back around or whatever. But still, you should be able to change the theme anyway. We won't get to quite a few things. One of the things that we just don't ever really get to in this course, but I do think is quite important, is compound figures. Okay, so very often you create a plot, you create a second plot, and you create a third plot, and they're really all kind of different views of the same data. And you want to actually put those all together in the same figure. So it's like one figure with 3 different frames, maybe outlined. So one is like taking up everything, and then you got 2 here, right? And that's very doable. It's not actually that difficult at all to put plots together like that into a single plot. Patchwork, which I have linked here, is probably my favorite package for doing that. You can also use cowplot to do that if you're interested in that. But patchwork is really nice. It's literally like, there's more advanced stuff you can do, but if you create one plot, you save it in an object called P, or maybe P1, and then you create a second plot, you save that in an object called P2. If you have patchwork loaded, you just say P1 plus P2, and you get a compound figure. Or you can put in parentheses maybe P1 plus P2, and then divided by P3, and then that would have the first 2 plots up top, and then the third plot would fill the entire bottom area, right? So it's like super extensible and really easy. We also won't get to exporting figures at all, except to talk a little bit about aspect ratio stuff, which is super important. And then the high data density part, it's not like the most important thing, but if you have a lot of overlapping points, it can be nice to add some additional things to it to sort of show the density of the data and not just like a big black blob, all right? So if you have that sort of thing, let me know. I mean, I'm not going to really talk about it, but I can help you sort of show that a little bit better. So the learning objectives for today: understand how to make a wide variety of tweaks to ggplot to basically make it look however you want, okay? And this is really important: understand common modifications to plots to make them more clear and reduce cognitive load, right? That's sort of what all of this is about in terms of building up visuals for communication, right? Again, different than exploration. If you're building it for communication, then you're probably going to spend a lot more time on that plot, and doing some of these things like direct labeling of points can be really helpful. All right, so axes. We often, most of the time really, use Cartesian coordinates, right? And so this looks like this. If they're on the same unit like this, then we have something like this, but very often we're using Cartesian coordinates with different units, okay? And if they're on the same unit like this, then really you probably should be using chord fixed, because a 1 unit change on the x-axis should correspond to a 1 unit change in the y-axis, right? But if they're in different units, which is most of the time, right, then you end up with something like this, which is fine, except you have this aspect ratio problem, right? This plot looks quite a bit different than this plot, and quite a bit different from this plot, right? And they're all like legit, right? There's nothing that is inherently like wrong about any of them, but you get a very different view of the data depending on the aspect ratio. So here's an example where you have like a visual artifact that is introduced by the aspect ratio, right? Here it looks really wide down here, and then it looks like they're very much coming together. Here, this is the exact same data, exact same figure, and you can see it looks like they're coming together a little bit, but it's not nearly as dramatic as what it looks like over here, okay? So this is problematic, right? It's problematic because you can show basically relations that maybe aren't real, or you can exaggerate relations, and it's not necessarily purposeful. In fact, I would say probably most of the time it's not purposeful, right? So like some general rules of thumb, this is a really weird plot, but it illustrates the point. If you have axes that are on the same scale, as I mentioned just a minute ago, then you you should be using chord fixed, right? Because then you don't have to worry about the aspect ratio at all, because it's just going to be what the data are. And so this is like showing temperature change. So like the line is actually representing time. So it's kind of weird, but so if we're not in that situation, which as I said is most of the time, then what do? Well, there's really no rule. There's no like even guidance really that I can offer you. What I can say is that you should try out a lot of different things and see what they look like. Okay, and you hopefully are familiar enough with your data by looking at it through other views that you know if something that you're showing is like a real relation. So like going back here, let's say that this is what you were showing and you would actually fit a model to this also, right? And you knew that this was not a significant like reduction in the space between those curves, right? If you knew that this was not significant, then this one might be a little more dishonest, essentially, than this one. If you knew they were significant, then I'm not sure which would be, right? This one certainly looks more like they're closing, and so then you just kind of have to use your judgment more. But again, this could be like we're now sure it's significant in terms of their closing, but maybe you're exaggerating what the effect really is, right? So just be careful of it. So keep visual perception in mind and try your best to be truthful. And like that's all I can really say. Know your data, so look at it a bunch of different ways, and then try your best not to exaggerate or hide specific trends and things, okay? Except when but when I say try out lots of different things, that means try out lots of different aspect ratios. And originally, I was going to have us do this. I have it here, but I'd rather not actually spend the time to do this right now. But I do want to actually, I'll just show you. Okay, so here is a function. This is by a guy named TJ Marr. He's on Twitter. This is, I don't know, he has like a thing where I think where he just automatically deletes his old tweets. But this is a really handy function, right? And there's a gist for it here too. So if we go here, here's the gist, right? So we can grab this and let's just actually grab all of this. Okay, and now I'll open a new window. I'm going to restart session, restart R. Okay, and now what I'm going to do here is run this function, and then I have this plot that I create here, right? And then I'm going to say, all right, let me see a preview of what that plot would look like with a width of 3 and height of 3 in inches. Okay, so I do that, and I'm going to have to bring my share up. And I get something that looks like this. Okay. Now I'm going to do it again, but this time I'm going to say, well, what if I have a width of 5 and a height of 2? Okay. Then I run that, and let me close this one, create a new share again. And I get something that looks like this. Okay. And what it's doing, what this function is doing, is actually saving the plot according to the dimensions that you specify, and it's saving it in like a temporary directory. And then it's bringing that plot up. So you're just previewing exactly what it would look like when you save it with those dimensions. And so you can try a whole bunch of different dimensions really quickly, and you can get a bunch of different views of different aspect ratios of the same plot. Does that make sense? So if you have chance, I would, if you have a chance, I would recommend that you do this, but we're not going to spend the time in class today because we're 45 minutes in already. So, but yeah, basically just create a plot, run that code for the gist right here, right? And then try out different aspect ratios and see what you think, okay? All right, the other thing that I wanted to talk about is scale transformations. And this is a little more tricky than you might think initially, all right? Very often, using a scale transformation can help you see your data better. It can also come at the sacrifice of interpretability because we're used to interpreting things on a linear scale. So if you're switching the axis to like a log scale, then people have to think in terms of a log scale, which is not nearly as natural as a linear scale. So you have to be very careful about this, but specifically for exploratory purposes, I think this can be really effective. And then from there, you can think more about who your audience is, whether they'd be comfortable interpreting a log scale or not. And maybe if you decide to go with a log scale, even if you're going for a general public audience, maybe there's some way you can communicate more information about that scale or really point out to them that this is not a linear scale, things like that, okay? But here's an example, right? This is a basic plot where we're using the Gapminder data. Here's the year and then the GDP per capita. So we can see we got this one line up here that's like huge outlier, and it makes it difficult to see any of the rest of the lines. So what we can do is just say scale y log 10, right? And then notice I've said labels scale dollar. So this puts this axis in dollars now, all right? But now this is on a log 10 scale. So we go 1,000, 10,000, 100,000, all right? So again, that's not linear, but these values are mapping to those values, right? So this is still the raw data. We've just changed the scale here. And so now we can see the spread of them a lot better, all right? Because most of the data is between 0 and 10,000, right? But then we have this crazy one that's way up here at 100,000, all right? So here's just another example, right? This is a linear scale. Now we've got it separated out by continent. And then if we put it on a log 10 scale, then we get something like this, okay? And so the blue line here is just like the average. Okay, scales, though, can get very tricky in terms of this sort of thing, okay? So here's an example where I'm creating some data where this is the raw data, right? The raw data is 1, 3.16, 10, 31.6, and 100, okay? Those are very specific choices, right? And then I'm doing these three plots, okay? So if we look at it like this is X on the raw scale with a linear x-axis, right? This is now with the x-axis transformed according to a log 10 transformation, right? So 1, 10, 100, okay? And finally, this third one is a linear scale. So the x-axis has not been transformed, but the data have been transformed, okay? So now this is log x. Okay, so in other words, we have taken the log of x. Okay, so notice I'm using scale x log 10 on the middle plot, but not either of these two. So these are both showing the raw data, right? They're mapping directly to the data, but this one, the data itself has been transformed. And so this gets tricky because you don't want to transform twice, right? I don't want to transform the data and transform the scale, right? That doesn't make sense. So what I want to do is instead transform one of them. And in this case, right, if I'm looking at it here, this is the raw data on the raw scale. It probably makes more sense to keep the raw data and transform the scale than it does to transform the data and keep the raw scale. Okay, you see why this is tricky, right? So don't transform twice. The other thing is you should probably try to be very careful about your labeling of these axes, right? So if you have transformed the data, then label the axis according to that transformation, right? So log 10 of x, that's what this is representing, right? Because I have transformed the data, right? Whereas here, this is x, this is the raw data, right? But the scale itself is log transformed. Does that make sense? It can be tricky for sure, but if you labeled this with log 10 of x, that would be ambiguous because is it the scale or the data that have been transformed? Okay, so what I'm advocating for is that the title match the data, not the scale transformation. Questions on that? Okay. All right, labels and captions. So APA style requires specific things. You might not be able to follow some of this stuff if you're creating an APA figure, but a lot of this still applies. All right, our book, the Wilkie book, uses a similar style to APA actually throughout most of it. So when we're thinking about the title, right, I've mentioned this already, but the title is, there's some research that says that the title is the first place that people's eyes go. And so that's where they're going to go immediately. And so your title is quite important, right? And so like John Byrne Murdoch said, he tries to make his titles so descriptive that after you've read through the title, the figure is almost like secondary, right? Like you almost get everything you need from just reading the title. So what's the point of your figure? What are you trying to communicate? This is a sort of minor point, but it's important. Figures should only have one title. And this is actually quite common because you'll have something in like a manuscript, right, where you're using ggplot and you put a title on the plot through ggplot, but then down below you'll say figure 1, blah, 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 right? And that's less than ideal because then you actually have two titles, one on top of the plot from ggplot and then one below saying the figure number and a description or whatever, right? So try to only have one title. Use integrated titles and subtitles when you're sharing with a broad audience in particular, but I think it actually helps overall. Yeah. So yeah, this is again just like minor advice, but this figure displays / shows, that's less than ideal. Just get right to the point, right? All right, then there's also captions, and we'll go through some of this stuff more. But when you're using a caption, I said consider stating the data source. That's a common use for captions. Other details relevant to the figure, but not important enough for a subtitle. Okay, so if there's something that you want to sort of reference or bring attention to, or sort of you know, give attribution for, or whatever, a caption is a good place to do that. All right, axis labels. So this is all sort of in the same vein, right? The label of the axis is the title for the axis, right? So this is very regularly critical for communication, and you should really never use variable names for the X and the Y axis if your purpose is communication, right? Again, that's totally fine for exploratory stuff, but once you get to communication, you should change what is the variable name on the axis title to be descriptive. What is it really, right? What is that axis representing? State the measure and the unit if it's quantitative. So brain mass, grams, right? Something like that. Support for measure millions of people. If it's a categorical variable, you probably won't need a measurement unit, but if you do need a measurement unit, then put it in there. The other thing that I would advocate for is occasionally, and actually relatively frequently, you can omit an axis title altogether. Okay, so here's an example where without including the x-axis title, it's pretty obvious what that title is. And actually adding an axis title there that says year or whatever might just add clutter and not actually help in terms of communication. Okay, so you have to be careful about this because it's not always going to be that obvious. But if it is super obvious what the x-axis is, then you could consider omitting the title of that axis altogether. Okay, so you can use labs x equals null or x equals nothing, basically. And then if you're using scale x or y, whatever, right, then there's this additional name argument. And so you would just say name equals null or whatever. Okay, but don't omit the title if it's not obvious. So here's the same plot now with the y-axis omitted, and that is very confusing now, right? Because what the hell do these numbers mean? It makes no sense, right? And so back here we have stock price indexed. Okay, that makes sense. Here it doesn't make sense. So I think it makes tons of sense to omit the x-axis in this case, not the y-axis. It's also it's also important that you not overdo it. So I said you should generally, right, include the measurement unit, but time, years AD, that's probably too much, right? And then this is like a lot of information here too. So this is, again, adding too much. And this is like, you know, you just kind of have to use your judgment on this. And sometimes the best way to get at this is by getting other people that are part of your target audience to look at the figure and give you feedback, okay? Annotations. All right, this is one of the most effective things that you can do for your plot is to add annotations to your plot. It's also one of the more difficult things to do in ggplot and to do it well, okay? So I'm gonna walk through an entire example using that same plot we just looked at, and we'll try to annotate each of those lines, okay? There's lots of examples though where adding annotations can be really effective. And sometimes I think it actually makes sense to get 98% of the way there with your ggplot code and then just save it and then pull up that figure in a different program to add the annotations at the end. All right, this is super common practice with like the New York Times or Wall Street Journal or whatever, any of the major outlets that put out data viz. They'll use their programming stuff to get a plot that's 95% of the way there, but then somebody else usually comes in with Illustrator or whatever to like circle lines and draw arrows to it and add little annotations. And you can do a lot of that directly in ggplot, but it's just going to be a lot more work, okay? So if you can though, you can add annotations straight in ggplot for a lot of them. And then if possible, try to just remove the legend at that point, okay? Because the legends are great, but they increase cognitive load because you have to kind of keep going back and forth between what's on the plot and what that means according to the legend. So if you can directly label things, you'll reduce cognitive load a lot. So here's an example, right? This is the package related to our book, and it has a bunch of different data in it. So this is that tech stocks data set that I was showing before. So we've just got the company, ticker, date, price, index, index. So we can start out here by just taking tech stocks, put date on the x-axis, price indexed on the y-axis, and then color equals ticker, right? And then we add a line and we get a plot that looks like this, okay? Then maybe we're gonna switch it so we now have a colorblind safe palette. That's good. And now I'm gonna change this because over here, right, this is not very interpretable at all, I would argue, okay? Because you've got basically variable name sort of stuff going on here. So what we'll do is I'll just say the name right within my scale color, right? The name is equal to the company. And then the breaks are going to be equal to all of those same things. And then the labels are equal to all of the different actual company labels. Okay, so now we get something that looks like this. And this looks a lot better, but I would argue this is still bad. Anybody have any idea why I would say this is bad? All right.
It doesn't match the order of the lines.
That's exactly right. Yes. So we have Alphabet here, which is here, and then Apple, which goes down here, and then Facebook, which is up here, and then Microsoft, which is here, right? Ideally, these would go, you know, these would go in the same order that the lines go. So top down, right? And so all we do to do that is we say, here's the breaks, and we put the breaks in the order that we want, and then we put the labels in those same corresponding orders, okay? And then we get something that looks like this, right? Company, Facebook, Alphabet, Microsoft, Apple. So they go in the exact same order the lines go, okay? So that's, again, going to reduce cognitive load. But even better, we can add text, okay? So let me just make sure. Yeah, okay. So here I have now, I'm expanding the limits on the x-axis a little bit because I need space for these labels, right? That's all that's happening here. And then I'm saying, okay, filter text stocks where the date is equal to 2017-06-02. So that's just like over here somewhere, right? And then I'm going to say, but Y is the price index, and then the label is equal to the company, and then the nudge X is equal to 280. How did I come up with 280? I tried a bunch of different values, and that's what worked, okay? So now I end up with something that looks like this, okay? And this legend at this point is redundant and not helpful, actually, because we have now these A's with lines through them, and it's kind of like doesn't really make sense, right? And these are all now labeled according to what they are. So we can get rid of that. But first, you can also see that this one is like pretty close. This one's pretty close, but then this one's like really far away. Why is that happening? It's because these geom texts are all centered to start. Okay, so if they're all centered, then this value that I had here is where like the number of characters is going to determine the left spacing. So instead, I do this h just equals 0, and that's going to make them left aligned. But I didn't change my nudge x, and so that makes them clear over here, right? So you can see we still have them, we now have them lined up here, which is good. That's what I want. But they're way over there, so now I'm going to change my nudge x to 20 instead of 280. And then I'm changing the color to gray 40. Because at this point, we don't really need those additional colors anymore because they're labeled directly, right? Also, I've specified guides color equals none here, and that drops the legend, all right? So I would argue this is now much better than having the legend, even when the legend is ordered correctly. You could also keep these the same color, and I don't think that would be bad. So I've changed them all to gray 40 because the labeling is so direct that it's obvious which one is which. If you wanted to keep those the same color, you could do that, and I don't think that would be bad by any means. But I've just chosen to drop the color here. Okay, just continuing on a little bit now. I'm going to drop the x-axis here. Change this y-axis, add a title and subtitle and caption, or not a subtitle, I guess, but caption, the data, where the data is from. On scale y continuous, I'm just saying the name is stock price indexed, and I'm changing the label so they're dollars. And then for scale x date, I'm saying the name is nothing, okay? And then we end up with something that looks like this, okay? So now I would argue this is a pretty good figure. There's still some more changes that we could make. I think those labels are actually maybe a little bit large, but that's not that big of a deal. Okay, so there's some stylistic things maybe that you would want to do, but overall I think that's a pretty good figure, and I think that's better than using a legend, because your eyes don't have to go back and forth between the legend and the lines to figure out which are which. It's very obvious. Direct labeling. Questions on that? Okay, this again is a super effective thing to do. It's been shown a bunch of times that it's really effective in terms of reducing cognitive load, but it's also quite difficult. It's not something that you can do like super easily with ggplot. It takes a lot of trial and error, and as I mentioned before, it depends on the aspect ratio. So if you get this perfectly figured out for your plot, and then you save it with a different aspect ratio, they'll all be messed up. Okay, so that's where that GG preview function I showed you earlier can be super helpful. Okay. All right, let's say you have a bar chart instead. So now I have the text stocks. I'm going to group by company and summarize. So I have a stock average where I'm just taking the mean of the price indexed. And then I'm creating this variable called share, which is just the proportion, right? The share of the stock. So we get something that looks like this. ggplot, ABS is what I've called it, averages, right? I'm going to factory order the company by share, then put share on the y-axis, then using geom call, fill with this color. Or I could make it horizontal instead, so I've just switched the x and the y-axis up here. I tend to prefer these, but I think that's more just sort of stylistic thing. Notice I put the alpha at 0.9 here, so only 10% transparency. That's kind of my preference to have just a little bit of transparency so you can see the guidelines in the background, but it's not like transparent really, right? All right, now I'm going to make this theme a little bit simpler, okay? Oh, I have chord flipped on here, so that's old code. But all I'm going to do here is say grid major.y, grid major.x, and or grid minor.x and grid major.x. So for these two, I'm saying for the major x and y, just remove them altogether. Or sorry, for the major y and the minor x, remove them altogether. So all we're keeping now is the major x. And I'm going to say for that one, we're just going to change the color to gray 80. Okay, and now we have a theme that looks like this, which I think is nice and simple and works well for bar charts. So what we could do, this is a real quick aside, right? I could create my own theme if I'm going to, for bar charts, right? Like if I'm doing a bunch of bar plots, then I might want to have this theme that I can refer to very quickly. All we do then is name it something. So I'm calling this BP theme, right? You say function and you put the dots, okay? Then you have these curly brackets, so you're defining a new function. You say theme minimal or whatever theme you're modifying from, put those dots there, okay? Then you say plus theme and you add all of those other things that you want to it. Okay, I've added one more thing here, which is I've said plot.title.position equals plot. That is my preference. Generally, it puts the plot title left justified instead of on top of the plot. Okay, left justified with the entire plot. Okay, so here we are again, where I'm now saying, all right, here's my bar chart, but I'm going to do geom text and put company on the X and share on the Y because I've done chord flip here. And then label equals share. Okay, so I'm taking the share and I'm rounding it to 2 digits. And I'm saying label these according to the share based on the X and the Y. All right. But then I have this nudge Y is equal to 0.02. That's going to shift all of these over a little bit. So instead of being right here, like right where the bar ends, they're shifted over just a little bit. Okay. And then notice I also have my plus BP theme here. Okay, so this is another example where you're using direct labeling, but you're using direct labeling based on just the value of the bar. Okay. So now doing a few last minute sort of things, changing the labels to scales percent. And so that means I need to up here say paste share times 100 with a percent symbol. Okay. And now I end up with something that looks like this. And notice this is what I was talking about. This is now left justified instead of justified at the 0 mark here for that plot.title.position. And then one other thing, what did I do here? I don't even know what's different there. I don't know. I did something different there. Maybe I just have the same thing different. Same thing twice. One other option here is instead of padding those things out to the right a little bit, we could actually pad them in towards the bars a little bit and then change the color to white. And this is actually my preference. So then we end up with something that looks like this. Okay, so then you're directly labeling like inside the bar, which I think actually looks the best a lot of the time. Okay, this gets tricky though when you end up with plots like the comic characters one I showed, where you have some bars that go way out there and then some bars that are tiny. Because if the bar is tiny, you can't label it inside like this, right? So then what you have to do is basically create a variable that says if the one variable like this x-axis is below a certain value, then you're going to pad it outside. If it's above a certain value, you're going to pad it inside. So that gets a little bit tricky, but it's not too bad. So if you end up in that situation, let me know and I can help you through it if you want to do this sort of thing. All right, distributions, we can directly label these as well. So here's an example where we have the iris data set, which I try not to use anymore, but I did here. So here's the 3 distributions, change the color, and now we're going to label them. There's a bunch of different methods that you can do for this. This is one method, right? I'm going to just create a new data set called label locs, right? The label locations. So I'm taking, if we look back here, right? Sepal length here. I'm going to say sepal length, and then I'm just going to put the values where I want those labels to be on the x-axis. Where do I want them to be? So I've said 5.45, 6, and 7. Okay. Then I'm creating a value called density, which is where they're going to be on the y-axis. And the only way I know these values is just by looking at the plot and figuring it out. Where do I want them to be? Okay. And then we have the species, which are just the 3 species. Okay. So these are the values, 1, 2, 3, for each of these 1, 2, 3 species. Okay. Now I go ggplot, create the density just like before, but then I say geom text, label equals species, y equals density, color equals species, and the data now equals label logs. Okay, so I've switched out the data source for the location of those labels. And we end up with something that looks like this. Okay, almost there, but not really, because we now have to say scale color in addition to scale fill. That matches the color. So now we should say we are probably good. We could just drop the legend. So we'll say guides fill equals none. But I've changed the text here. So now I've taken it out of the AES. And I've just said color equals gray 40. If you wanted to keep the color, again, you could do that also. You just have to say guides fill equals none, comma, color equals none. And then that would keep the color also. Okay. Questions on that? All right, this is like we're kind of flying through this, and I think it probably makes sense to watch it, but it is one of those things where it takes a lot of fussing with it, and it can be fairly difficult to do. So it's going to take some trial and error to get this right, but what I'm trying to advocate for is doing it, is taking that time to do it, because it will reduce cognitive load and make your figure easier to interpret. Okay. And again, I would not do this unless I was ready to say, okay, this is a plot that I'm going to build out for communication, for something that I'm going to actually try to publish in some way, right? Because then it's worth the effort. If you're not going to communicate this with other people, it's not worth the effort. Okay. Other options, there's another function within ggplot called annotate, which can be used for a bunch of different things. One of them is text annotations. All right. I kind of prefer the data frame method, but you can also use multiple lines of annotate to do the same thing. And one of the things that's nice about annotate is geom text. I don't know the exact reason why, but sometimes geom text can end up with the text itself looking fuzzy, and annotate will always be really sharp. Okay, so if you end up with fuzzy looking text in particular, then you'll want to move away from geom text and move towards annotate. Okay, but it just looks like this. You say annotate, you say the type of annotation that you want to do, so you can do like rectangle annotations and all sorts of different things. But for what we're talking about, it's always going to be text, right? You want to do a text annotation to your plot. Say the label, and then give it an X and a Y, and then a color. Okay, so I'm saying gray 40 on all of these. And that's it. I take those same values I had before, and when we add them, it looks like this. Okay? So this is basically the same sort of thing. We're just doing it through 3 lines of annotate now, rather than creating a new data set and then, or data frame, and then adding a layer for that data frame. So this is probably preferable in cases where it's small like this. If you have a lot of things you need to label, then I think the other method is preferable. But like I said, this method also will basically guarantee that you'll have sharp text. And in the past, anyway, maybe this is something they've fixed, I don't know, but geom text would occasionally create sort of fuzzy looking text. Okay, we only have about 5 more minutes, so I want to talk about ggRepel real quick. One of the other things that you can do very often is sometimes your points themselves have text that are associated with them, right? So here's an example where I'm plotting the relationship between horsepower and miles per gallon, but each of these points represents a car, right? And so what I can do is just take, in this case, the row names, which tells me what the car is, and then label them according to that thing, right? So now instead of plotting points, I'm actually plotting labels, okay? Does this work well? No, not particularly, because we've got a lot of overlapping text here, right? And maybe if we could expand this thing out so it was a gigantic plot, then it would work well. But for this case, it doesn't particularly work well. So why am I showing it to you? Because for some cases it will. And the other thing is we can use other tools to help us do basically the same thing by using repelling. Okay, so we use this package called ggRepel, and now instead of saying geomText, we just say geomTextRepel, and otherwise it's the exact same. And what we end up with are all of the text is being plotted at that point, if it can, and if not, it's being repelled, so it's being moved away, and then there's a line pointing at where it is, right? So this is still pretty busy, right? But it at least gets us a lot closer. We can also add a point layer first and then add the text layer, and then we get something that looks like this. So again, I would say this is quite close, or getting quite a bit better. Notice I've also added this additional argument, minimum segment length, and that is going to just always have this little line. So then it's pretty unambiguous which label is going to which point. Okay, so common use cases for this is, let's say there's some points that we want to label and others that we don't, right? You can use geomTextRepel to just subset your data to just those points and then call geomTextRepel. So for example, let's say we wanted to label some outliers. All right, this is a different data set. I've computed some means by country, so it looks like this. And we can create a scatter plot that looks like this, all right? So by country, GDP mean, and then the health mean. Now, I'm going to say, okay, let's do geomTextRepel, where I'm going to say the data source is, we're going to filter by country, the thing that I'm plotting up here, where the GDP mean, the x-axis, right, is greater than 2,500, or it's less than 25,000. Or it's less than 20,000, okay? And then I'm going to say label by country. And so now we end up with something that looks like this, right? So now we're just labeling those outliers. And that's pretty straightforward, and it's really helpful, right? If there's reasons to call out those points, okay? We can also combine this with highlighting that we looked at before. So I'm just calling ggHighlight on that and geomTextRepel on the same thing. And now we end up with something that looks like this. But this is maybe doing the opposite of what we want. It's emphasizing those outliers and de-emphasizing the middle. Maybe that's what we want to do. I don't know. But we could also do it the opposite. Okay, so now we're emphasizing the bulk of the data and de-emphasizing those outliers, but we're also labeling those outliers so that if you're interested in them, you know specifically what country that is. Okay, and whether these are the right points to label or not is sort of not the point, right? But we can very effectively, very quickly do this, all right? The last thing I want to show is that you can also pretty easily label them by some other variable, right? So here I'm labeling them by the consent law, whether it's presumed or not, okay? So using ggTextRepel on whether the consent law is presumed, and you get all the presumed countries labeled. And then we can do this with ggHighlight as well, and you get things that look like this. Okay, so to me, this is a pretty effective plot, and it's fairly straightforward, right? You're just saying, instead of using color to highlight these two different groups, right? I'm going to use highlighting, use color as a tool to highlight and directly label them, and then we have a pretty effective plot. Okay, So I'll start at ggforce. Next time it does a lot of cool stuff like this. And we'll go over that a little bit next time, and then we'll move into the other parts, which is uncertainty. Okay, and that'll be after reviewing homework 1 as well.